Okay, so let's get started today with our second day of systems of inequalities. If you remember back to yesterday, we were looking for the solution to a system of inequalities, which meant we were looking for the double shaded region. So where both equations are true. So let's do some problems today and see if we can figure out our solutions. Okay, so looking at these, we can see that both of them need to be solved for y. So let's go ahead and start with our first problem. So negative 3x plus 2y less than or equal to 8. I'm going to add my 3x. I have 2y less than or equal to 3x plus 8. And divide by 2. Y is less than or equal to 3 halves x plus 4. 8 divided by 2 is 4, and 3 over 2 is not going to change. So I'm going to start at 4. 1, 2, 3, 4. And I know I'm supposed to go up 3 and right 2, but I can't do that because my graph is too small. So the opposite would be down and left. Remember, this is a positive slope, so my line needs to be going in that direction. So 1, 2, 3, 1, 2. And I can do that again. 1, 2, 3, 1, 2. And I have my first line. And I see that this is equal to, so I know that I'm going to have a solid line. So let me go ahead and get a solid line going here. And we need to do some shading. So let's take a look at the problem and decide which direction I am shading. So remember, if it's less than or equal to, I am shading down. And greater than or equal to, I'm shading up. Okay, down and to the left or up and to the right. So if I take a look at my first problem here, I've got my less than or equal to. So less than means I'm going to be shading down. So my first shade is coming this direction. I'm shading down. Okay, let's go ahead and solve the other equation. So I'm going to go ahead and solve that one over here on the left-hand side. So 5x plus 2y less than or equal to negative 8. Remember, we're going to subtract our x's. So 2y less than or equal to negative 5x minus 8. And I'm dividing by 2. So y less than or equal to negative 5 over 2 is not going to change. And negative 8 divided by 2 is a minus 4. So I'm looking at y is less than or equal to negative 5 over 2x minus 4 as my equation. So negative 4, 1, 2, 3, 4. And I know that my line is supposed to be going towards the negative, but I cannot go down. So instead of going down and to the right, I'm going to go up and to the left. So 1, 2, 3, 4, 5, and 1, 2. I see that I have my intersection point. So let me go ahead and draw that line. And again, it is a solid line because it is an equal to. So I have a line coming through these points. And my graph is saying that it is a less than or equal to. So that means I'm shading down again. So shading down means I'm shading this direction. Okay, so there's a couple of things that we need to identify here. The first thing is the point of intersection. And I see my point of intersection is actually right here. So that ordered pair is negative 2, and it's up 1. So there's my point of intersection, negative 2 comma 1. And my solution is where the double shaded region is. So I'm going to take my orange pen and I'm going to color in this section because the solutions are where the two colors match. Where the two colors match. Okay, let's go ahead and work on this next one. So I have negative 3x plus 2y is greater than 6. And remember, on these, when we're solving inequalities, I have to flip the inequality if I'm dividing by a negative, but I haven't had that come up yet, so I haven't had to do any flipping. So I'm adding my 3x. 2y is greater than 3x plus 6. Divide by 2. Y is greater than 3 over 2 is going to stay the same. 6 divided by 2 is a positive 3. So there's my first equation. So I'm starting at 3. 1, 2, 3. And I'm supposed to go up 3 over 2. I can't do that. Remember, this is positive, so the opposite would be down and left. 1, 2, 3, 1, 2. And I can do that again. 1, 2, 3, 1, 2. And this time it is a dash line. It is a dash line, so I need to go grab a dash line. And again, I'm going up. Okay, so it is greater than. So if I am greater than, that means I am shading up. I am shading up. So I am shading above my line. Shading up. All right, now the next one is y is greater than or equal to 3. So y is greater than or equal to 3. 1, 2, 3. So I see where they're touching. They're going to be touching at 0, 3. So I know where my intersection point is. Well, what does this line look like? Well, I know that it's going to be solid. So I know I can grab a solid line. But the other thing I need to realize is this is a 0x plus 3. So it is a horizontal line at 0. So I have my line coming through right here. And let me change that color. Go ahead and make that red so we can see it. Okay, now this is greater than. So where are the numbers greater than 3? Well, greater than or equal to means shade up. So if I'm looking at shading up, I'm above this line. That didn't work out. Those colors not going to show up very good. Let me throw some red in there. There's my intersection. So I'm shading above the line. So my actual section of intersection, where the double colors are, comes right in here. So my solution is up there in the right hand or in the upper left hand corner where both colors are. Okay. Let's take a look at this problem and see if we can figure out which inequality is represented by this. So we know that the inequality is 3 halves x minus 3. That's the same all the way. The question is it greater than, less than, greater than or equal to, or less than or equal to? So if I take, first thing I want to look at is the line. Well, I see the line is solid. Okay, so I see that that is solid. So I know it has to be either greater than or equal to or less than or equal to. It has to be those two. So these two are gone just because of the type of line. Now, here's my intercept. This direction is up. This direction is down. Which direction is shaded? Yeah, it's the down. So if it's down, I know that that means I'm talking about smaller numbers. So it's less than, which means it's got to be pointing to the left. So my equation should be y is less than or equal to 3 halves x minus 3. Okay, so I want you to take a minute, hit pause, see if you can figure out the M and the B for the black line, the M and the B for the red line, and the inequalities. Okay, let's see how we did here. So here's a 4, so I know that's my B. And I need another good point. So here's a good point right here. So this is down 1, and over 2, but I need to pay attention to how I'm counting here. So this is really down 2 and over 4. So negative 2 over 4 is really negative 1 over 2. So I need to watch my scale. Not every time I look at this, it doesn't necessarily mean my numbers are 1. So my equation I know is 1/2 x plus 4. So am I graphing above it or below it? And remember, there are 4 choices. I have less than, or equal to, greater than, or equal to. So I see that the first thing that I see is that I see it's a solid line. So I'm talking about either this one or this one. Am I shading above the line or below the line? Well, I'm definitely below the line. So if I'm below the line, that means I'm talking about less than. So less than or equal to, because it's shaded down. All right, let's take a look at the red one. So I'm talking about a y-intercept between 0 and negative 2. Well, that has to be negative 1. That has to be negative 1. And I cannot use that point now because it really isn't a very good point. But let's see if we can find something that looks like it might be a good point. So I know this is going to be in the middle at 3. So from negative 1 to 3, that's 4 and a 2. 4 and a 2. So my slope is 4 over 2. So I know that's positive, and I also know that needs to simplify. So if I simplified that, that's going to be a 2 over 1. So 2 over 1x minus 1 is that equation. Now, am I shading above the line or am I shading below the line? I'm still shading below the line, so it's still less than or equal to. Okay, it is still less than or equal to. Let's try another one. This one is counting by 1, so it'll be a little bit easier to find our slopes and intercepts. Let's start with our blue line, and then we'll go to our red line. So hit pause, see if you can come up with your M and your B and your inequality, and let's see if you can come up with an answer. Okay, so if I take a look at my blue, I see I have an intercept at positive 3, and I have another good point here. So if I count, I'm going up 2 and over 3, so my slope is 2/3. So I have 2/3 x plus 3. Now think about our signs here. And which one is right? What do you think? I'm shading above the line, and it's an open line. So if it's open line, it has to be one of these two. And I'm shading up. So that means it has to be greater than. I'm shading up. Okay, let's look at our red line. So red line is at negative 1. And another good point, looks like there's one right there. So that's 1, 2, 3, 4. I'm going down 4. 1, 2, 3, 4, 5. So my slope is negative 4 over 5. So negative 4/5 x minus 1. Okay, so what do you think? Which one of these inequalities is it? Am I shading up or am I shading down? I'm shading down, so it has to be one of those two, and it's a solid line. So I know that I am less than or equal to. Okay, so now let's determine some solutions. Let's decide what is a solution, what is not a solution, and then why or why not. So remember, there's a difference between solid lines and open lines. Okay, remember there's a difference between those. Let's go ahead and figure out what these points are. Where is 2, 0? So remember, the 2 is my x value, and the 0 is my y value. So if I'm talking about 2, 0, I'm talking about right there. So is 2, 0 a solution? Yeah, it's in the double shaded. So if it's in the double region, I'm good. What about negative 4, 0? So negative 4, 0 is here. Is that a solution? No, it is not. It is outside of the double. So it does not count. What about negative 2, 0? So that would be here. It's on the black line. So what do you think? Is it a solution? It's a solution to one equation, but it is not a solution to both equations. So even though it is on the line, it is not a solution because it's not in the double. What about 1, 4? So 1, 4. So over 1 is halfway, and 4 is right here. So I am on the open line in the double shaded region. So what do you think? Is that a solution? No, it's not. Because of the open line. Okay, because of the open line, it is not a solution. Now, if I be here on the closed line, that is a solution. Okay, that is a solution. This one is not a solution. Now, it doesn't make any difference if I'm in the orange section. That is also not a solution. And the blue section is not a solution. The only ones that matter are the ones that are in the gray area, okay? The gray area and then on the black line, the solid black line, because that is the ones, those are the ones that are equal to. The open line does not count. Okay, we're done for today. Go ahead and see what you can do with your homework and reach out to us.